When hydrogen burns, it generates energy in the form of heat, with water as a byproduct. That means energy created from hydrogen generates no atmosphere-warming carbon dioxide, making it one of the many potential energy sources that could help reduce carbon emissions and slow global warming. But creating hydrogen and transforming it into a useful format requires energy, and that energy is not always necessarily renewable. That process is also inefficient and expensive compared with other forms of energy, renewable or otherwise. Producing hydrogen takes energy because hydrogen atoms don't exist on their own. They're almost always stuck to another atom, often another element. In the energy business, people generally refer to hydrogen by an array of colours as a shorthand for how it was created. Although this serves a purpose, it's not an ideal solution because it doesn't indicate how much carbon was produced in order to obtain the hydrogen. Firstly, green hydrogen is when the energy used to power electrolysis comes from renewable sources like wind, water or solar. Electrolysis is used to split the water into hydrogen and oxygen. Blue hydrogen is hydrogen produced from natural gas with a process of steam methane reforming, where natural gas is mixed with very hot steam and a catalyst. A chemical reaction occurs, creating hydrogen and carbon monoxide. Water is added to that mixture, turning the carbon monoxide into carbon dioxide and more hydrogen. If the carbon dioxide emissions are then captured and stored underground, then the process is considered carbon neutral, resulting in blue hydrogen. Grey hydrogen is made from natural gas reforming in the same way as blue hydrogen, but without any efforts to capture the carbon dioxide byproducts. Pink hydrogen is made from electrolysis powered by nuclear energy, which does not produce any carbon dioxide emissions, although nuclear energy creates radioactive waste, which must be stored safely for thousands of years. Yellow hydrogen is hydrogen made with electrolysis from the energy grid. The carbon emissions vary greatly depending on the sources powering the grid. Finally, turquoise hydrogen is produced from methane pyrolysis, or splitting methane into hydrogen and solid carbon with heat in reactors and blast furnaces.